All right, to start with, we're talking about linear regression. It's just a little tiny part of this unit, but it's actually, I really think we gloss over it too fast because this is powerful. To be able to take real world data and then be able to put that into a equation that can then answer questions, that's something you could really use in your real life. A lot of business owners could use this and track their sales and say, well, if I keep on this trajectory, by, year 7, I could be at how many sales or whatever. All right, so anyway, you've entered this into list 1. Then what was this calculator sequence? You go to stat, calculate. What's the next thing after you say stat, calculate, linear regression, linreg, okay? Then after stat, calculate linear regression, you have to tell it to draw its info from list 1 and list 2, L1, comma L2, and then the last one, if you have the old operating system, you'd say comma Y1. If you have the new operating system, it asks you where to store the regression equation, and that's where you'd put the Y1. The Y1 was found under vars, and then what? Y-vars, and then what? Function, and then you get your Y1. All right, now that it's in the regression equation, it would be y equals, and then if you go on your y equals screen, would you please read me, Miss J, the equation? 1.68x plus 6. All right, and then, do you get, I could just do this by hand in my head. I could take this 7 and stick it where in that equation? This is the x column, right? And this is the y column. So yeah, that's an x. So x is 7, so you put a 7 right there. I could have done that. Or I could go in and hit graph and then do second calculate what? Value. Second calculate a value of 7. All right, now I want to go to parabolas. So let's put in this parabola. Let's say the person is throwing the ball at 10 meters per second. They're throwing it pretty fast. They're throwing it straight up because we're going to really limit this to just the vertical velocity. All right. And I hope you already know the beginning of the equation. How does it always start? If we're using meters, unless you're on a different planet, it's going to be the same one. It's the gravitational constant, which is negative what? 0.9, I think. And then t squared or x squared. And then what did I just say that goes next? Plus 10x or 10t. And then you should ask me one thing I haven't told you yet. The release point. All right, let's say that he's throwing underhand. He's got this really fast upward throw that he releases at 1 meter. Okay, would you please now figure out for me what's the highest the ball went? I'll pause for a second while you give that a try. Okay, so when I put this in and hit graph, you can tell mine really is zoomed in a pretty bad spot. If you can't see the graph, you want to zoom out far enough so you can see it. But now that I can see it, my graph, I need to kind of zoom in. I personally like the zoom box, so I'm going to show you again how you do zoom box. And I'm going to box in the area that I want to see better. So I'm going to start the upper left-hand corner of the box first. And I'm going to start it about there. And then I'm going to drag this around the part of the graph that I really care about, which is where it has its peak and where its x-intercepts are. And now I can see much better what my graph looks like. Okay, it looks to me like about 2 seconds in the air. Does that seem right to you? All right. Well, let's find out if that's really, really right. We'll find out. I didn't ask about the in the air time. What I asked for was the highest it went, right? Okay, so let's do that first. I'll go second, calculate the, not value, the, what is it? Maximum. And I hit enter. And then I got to set up a left boundary to the, that's on the left side of it. Here's the right hand boundary. As long as I'm to the right of the top. Guess means go right on top of it. Hit enter. And did you say 1.02 seconds? It was at 6 meters. Raise your hand if you had that one right. Okay, good. All right, now let's extend this question. Do you get that if I wanted to find this spot where it hit the ground, that would be also called a 0? And you'd go to the left of it, to the right of it. Okay, so that'd be another thing I could ask you. The last thing I could ask you would be, when did the ball cross 5 meters? It's kind of a trick question. How do I put 5 meters on this graph so I can see when this crossed it? Yes. Exactly. Go to y equals 5. And then I can see there'll be a line going across there when I hit graph. Cool. Then I can tell when this ball went 5 meters high. Would you, with your partner, figure out how to do that? I would use second calculate, and there's something there that help you find it. Find exactly 2 times, once on the way up and once on the way back down again. I'll pause while you try that. Okay, I'm recording again. So how do I find these spots? Second, calculate, intersect. I hope you found it was the intersect one. Now it asked me first curve. That just means am I on the first of the 2 lines that are intersecting? And I am. And it'll always be, if you only have 2 lines, it's really simple. Just hit enter and enter. It'll jump right to the 2 lines. It's only if you have 3 lines graphed that you got to be clear about which ones you want to find the intersection point for. So if you only just do 2 lines, the first 2 are just enter. Then guess, get close to it, and hit enter again. And there it is. You should have said at about a half a second that it was at 5 meters. And you do the same thing on the other side. Save me some time. What was the other answer? 1.5 about, so about 1.5 seconds. It was crossing 5 again, right? All right, good. Okay, next, what if I wanted, where is the ball at 2 seconds? Feel free to confer with your partner. Okay, should have done second, calculate a value, and it says x equals, and then you know you're on the right track. X equals, that's time, right? Time is 2, hit enter, jumps over to there, it's at 1.4 chickens, right? The units will be very important here. 1.4 watts, meters, and that's the what. That's how far the ball was away from you, true or false? That is how far the ball was off the ground. Okay. Just needed you to understand what we're doing here, not just like, okay, you do this little thing on the calculator, but I can't relate it to the real world. All right, so your next thing, you're going to be looking at a equation. I hope you remember that form. That's called vertex form. So what's the vertex? Do you remember? Vertex is that spot that, you know, like goes like this. What's the vertex for this one? 3, 1. Very good. Okay, so I didn't probably draw this right, but I'll go over 3 and up 1, 2. Let's say it's right there. And there's my parabola. Okay. Do you know how to get vertexes out of general form? Well, for one thing, if you can factor it, if you can factor it, you should, right? In this case, I didn't make it factorable, so you can't factor this one. What if I did make it factorable? Made this minus 4. Would you please factor it? We'll see if you figure out what that means when you get it factored. If you understand this, you should be able to make a sketch of this parabola after you've factored it. What I'm doing now is just kind of a power review of what you learned in Honors Higher Algebra. I know because I teach that class. I'm teaching it this year, so I know what you had last year, and I taught it for many years before that. So I know you taught this stuff, but whether or not you remember it is a different thing. But that's one of the reasons we're going to go pretty fast. All right, I should have said x minus 1, x plus 4. Raise your hand if you had that. Awesome. Then do you get that you now have found the roots? Positive 1. Nope, I did that on the wrong side. Positive 1 would be here, and negative 4 would be here. And this parabola has to be going upwards because there's no negative in front, right? And so therefore, I can find the vertex by saying it must be on this line that runs right down the middle. There's a way to do it that way. But if I want to find the vertex, there's the fast way too. Do you remember that we did the quadratic formula And that would also find these roots. If you haven't memorized the quadratic formula, that'd be pretty sad. X equals negative plus or minus b squared minus all over. Awesome. Good. And this part tells us stuff. If that part is 0, then it knocks out one of the solutions. So you have how many solutions? Only one solution. And when this part is 0, that's all gone. And plus and minus 0 is kind of irrelevant. So that's gone. And you're left with this. Do you remember what that is? That tells you the vertex. That tells you the vertex. And I even told you that that would tell you the vertex for anything, not just ones where b squared minus 4ac equals 0. That formula right there. So would you please use it and figure out what the x of your vertex is? That'll be this little line that runs down the middle. It's not a nice number necessarily. It isn't always like, ooh, it's -2. So it's -3 over 2 times 1, which is 2. -3/2, which is -1.5. That was this line running right here. Okay, wait, Mr. Server said you're going to tell us the vertex. That's the x of the vertex. So this point right here has an x and a y, and I know the x of it, -1.5. How do I get the y of it? Somebody remember last year? Yes. You just plug it in. You know x is -1.5. Put it in. -1.5. Now this happens to be a decimal, but it makes it work not quite as clean and nice. So I'm going to make one there that would work clean and nice. But I wanted you to show you that this would work for any equation. It'll tell you the vertex, the x of the vertex. All right, so here's one where it will be clean and nice. And it starts right there at 4,2. No, 4,1. Sorry. To make it clean and nice, I made redo this. And I'm going to have it go upside down like this. And that means it goes through the points 3 and 5. And I know its vertex, because I just told you a second ago what its vertex was. Well, we're going to act like we don't know what the vertex is and see what we could have known. Would you agree that this equation would have been x minus 3 and x minus 5? Would you get that much? Then multiply that out. We'll know general form for this parabola. X squared, outside inside, makes what? Minus 8x, and the lasts make 15. All right. Now, oh wait, it's upside down. If this is upside down, what's missing from my equation? A negative. I need a negative in the front. That makes everything the opposite. Negative x squared plus 8x and minus 15. And what little formula did I just say 2 seconds ago would always tell you the x of your vertex? It's the beginning of the quadratic formula, the front part. X equals -b plus and minus blah, 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 all over 2a. It's this part. That part tells you the x of your vertex, -b over 2a. All right, so what's -b? Well, here's our b term. -b would be -8. Put it right here. Question? Over 2a, and a is -1, so 2 times -1. That makes -8 over -4. What's that? You get how I just got the x of my vertex? I already know the answer is 4,1, but I'm just trying to show you how you can find it using this. All right, so if I have -b over 2a coming out to this, that means x is that. X is 4. The dotted line that runs down the middle is x equals 4. And then everybody struggles with what to do with that 4 to get the other part of the vertex. Just start by writing it and go, well, I know it's 4 comma something, And then what did I say you should do with it? Plug it back in. You can put it in either form. This is the same exact thing as this is, so I like this better for this. I like to put it in the factored form. So I'm going to stick my 4 here and here. What'd you get for this? 1. What would you get for this? -1, and there's an extra negative here. Do you see how that'll come out to 1? And that's how you can find your vertex manually. Now you might be thinking, I'd never do that. I'd graph it with a calculator and see where its vertex was. Not if we throw a letter into the equation. You won't. You know what I'm saying? We throw a variable into your quadratic formula, and that's the same thing that could happen in the ACT test. They want to get away from problems that you can just solve with the calculator. I definitely have noticed that they want to, over time, seems like they want to have less and less reliance on the calculator and more just like you understanding things better. So they throw in a variable, so you can't just do it all on the calculator. All right, so to sum it all up, I gave you any quadratic. Hey, there you go. You should be able to tell me the vertex with that little formula, the beginning part of the quadratic formula. I know we glossed over that part really quick, so that's why I want to spend more time on it today. This part, I don't even care about. Not if I want to find the vertex. And I know some of you are thinking the picture of this, and then you'd be like, I know what the vertex is already, Mr. Server, but bear with me. It's -b over 2a. So what's -b? 0. What's 0 over anything? 0. X equals 0. And then what do I do with that if I'm trying to find the vertex? That's, which part of the vertex is that? That's the x part, and therefore I stick that 0 in here, and I get 0, 8. So it'll work with even weird-looking ones. Here's another weird-looking one. You believe that's a parabola? Okay, then figure out its vertex. Every parabola has a vertex, right? -1/2. I now know that the vertex is -1/2 comma something. Finish it off. What'd you get? Help me. Nobody can do that fast? 1/2 times 1/2. Negatives will cancel. 1/4. 1/4 minus 1/2. Would it help if I made this into fourths? 1 over 2 is 2 over 4. 1/4 minus 2/4, which would be -1/4. There you go. Even a weird one. You can find the vertex of it. Okay. So now, we've talked a lot more about what you'd need for that lab. I've decided that tomorrow during the test, I'm going to have you walk up and measure yourself on the board so that you can have all the data you'd need so that over the weekend you could complete the lab if you wanted to. I'm not going to make it due Monday, but if I were you, I'd try to get your lab done this weekend because I will have that up on the board. You come up, measure yourself, see where your eyes are, and go, okay, I'm going to use 83 inches for that or whatever. We should do it in meters, though, shouldn't we? Yeah, I'll do it in meters, and we'll do it in parts of meters. Question? You going to be gone or something? All right, I'll set it up for you at the very end of the hour. All right, so let's see. One more thing. Do you remember we had a thing where we would have 2 points, and you could get the equational line through those 2 points? That should be second nature by now. Done it on a test. We had it on the top 28 million times. So then how about I take this green point, which is over here, and I say I want a line parallel to those two. Well, I need to find these guys what then if I need it parallel? Slope of those guys. And then would I make my line have the same slope or some other slope? Same if you want it parallel. What if you want it perpendicular? That's the opposite, but not just the opposite. Opposite reciprocal. All right. So I'd like you to very quickly figure out the equation for a line going through the point 1 comma 6 and being perpendicular to this line. Work with your partner. Come up with the right equation. Okay, help me. What's the slope of the red one? 7 minus 5 over 4 minus 2. What'd you get? 1. So the slope is 1. So then this guy's slope needs to be the opposite reciprocal. With 1's kind of weird because this reciprocal is still 1. So then it's just negative 1. So then I want m to be negative 1 on this line with this point. If I had a slope and a point, I'd use point slope. Y minus the y, which is 6, equals m, the slope, negative 1, times x minus the x, which is 1. There's an equation, which, yeah, you could solve it for y if you wanted to, but raise your hand if you had that. Awesome. All right, so we've reviewed a lot of things. In a moment, you're going to be leaving. What would I do if I were you? Well, bottom line, I'd probably study. How would I study? I would look at answer keys and worksheet problems, 2 problems we skipped, and that's all I got for you for today.